All right, express the point in rectangular coordinates. Well, what we're saying is that, as it's shown here, r is 2 and theta is 5, 6 pi. We have these identities that we use, that x is equal to r cosine theta. So that's going to give us that x is equal to 2 times cosine 5, 6 pi. And so I have to evaluate that. Y is equal to r sine theta. And so that's going to give us 2 sine 5, 6 pi. Briefly, or not, but I think it could help a lot, is I will try to figure out where 5, 6 pi is. So let's see, here's pi, and I can write that as 6, 6 pi. 5, 6 pi will be just a little bit above. And the reason I care about that is that it's in the quadrant 2. And so quadrant 2 is x coordinate is negative, y coordinate is positive. And cosine is the x coordinate, and sine is the y coordinate. So for the cosine, I'm going to get a negative. Cosine 5, 6 is going to be negative. Sine will be positive. All right. Now let's fill in the blank of, if I do have a reference angle of pi over 6, can I draw a triangle that corresponds to that? Well, I think I can, because pi over 6 corresponds to 30 degrees, and we can sort of see what the shape of that 30, 60, 90 triangle is and fill that in. And cosine 30 degrees is adjacent over hypotenuse, so that's rad 3 over 2, which I fill in. And then sine of 30 degrees is opposite over hypotenuse, and so that makes 1 over 2. I fill that in. And you can see that that makes sense on this picture I've drawn of the unit circle, that the y coordinate will be, which is 1/2, is less in magnitude than the x coordinate, which is negative rad 3 over 2. So fortunately, I need to move this over to get the answer. Write this down. It's negative rad 3, 1. So the answer, I'm putting this in xy coordinates. It's xy equals negative rad 3, 1. Some people don't like to put equality between points, but some people do, and I'm just going to do that. But that's our answer. That's our answer right there. Center it a little.